Alright, so with number 2, we needed to distribute first. We have 8 minus 6x minus 18 is less than 4x minus 5. Combine your like terms on the same side, so 8 minus 18 would give us a negative 10. And then pick and choose what you want to move. Let's say I add 6x and then add 5. If you did it the opposite way, that's fine. So we'd have negative 5 is less than 10x, and we'd be dividing both sides by 10. So if you got a fraction, that was okay. The sign would not change here, but because this is backwards, you'd have to read it backwards, or you can flip it so it makes more sense. Just make sure whatever this is pointing to or away from does the same thing. And then your number line can be whatever you want it to be. So if you want to put like negative 1/2 here and then start counting by whole numbers, you could do that. So this would be 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, 4. Not accurate in counting, but that's okay. So this would be an open circle going to the right. Questions on that one? Number 3, you have to solve first, and then it asks you about these values, so we'll come back to that. Distribute. That is 18 over 3, 6. 30 over 3, 10. Get all your variables on the same side. And divide both sides by 18. So again, another fraction. 1/3. Or x is greater than 1/3 if you flip it. So you would have to figure out which of these numbers are bigger than 1/3. 1/3 doesn't work because it doesn't say equal to. Negative 1 is not greater than 1/3. 1 is, and 2.5 is. So those last two. That's a good way to check yourself. I think I said that last class. Pick some values, see if it's greater than or less than. If it's not, you have to draw it the other way. Questions about that one? For this one, I would say leave it as a fraction because this would be a repeating decimal. So unless you're going to put 0.33 like at least 7 times, just leave it as a fraction. If it was like 0.5, then that would be fine. All right, and then for the last one, if you got to this one, you may have gotten a weird answer. I'll explain why it's weird here in a second. So distribute. We have 8 plus 18x. Combine your like terms. We have 18x minus 7 is greater than 8 plus 18x. You may have been thinking this might be like a infinitely many no solution case, but that's not a thing here. So keep solving. Let's say I move my 18x, I move my 7, so everything canceled here, I have 0, and on this side I have 15. In this case, instead of no solution, infinitely many, we're just looking at, is this a true statement or not? So is 0 greater than 15? No. So we would just say this is false. Not that it doesn't have a solution, not that it's infinitely many, but it's just false. This statement is false. Okay. Questions on that one? All right. Today, we're going to talk about the next part of our inequalities, compound inequalities. So you all should have these notes in front of you. This may be new to you. I don't believe this was taught in an algebra course unless you were in advanced, possibly, but 2 years ago, I don't think this was taught. So, definition of a compound inequality: two inequalities or more joined together with and or. So I'm going to show you the different types. We'll do a couple problems from each, and then I'll show you how Khan Academy is a little different, because of course it always is. And then we'll go through a couple of those. Anyone still writing down this definition? Okay. All right. So let's start with one of the types, the or. In our class, when we take the quiz, when we take the test, our practice, our or inequalities have a tendency to graph apart. And we'll see what that means here in a second. So if we had, like we solved it, and we got this as our answer, x is less than or equal to -2, or x is greater than 3, you would draw both of them. So this would be closed circle at -2 going to the left, open circle at 3 going to the right. And it would look like that. Your interval notation, that's, remember, your brackets, your parentheses, as we're reading left to right. From the left, it still starts at -infinity. Then it stops at -2. And that would be a bracket because it's closed. Or it starts again at 3, but that one's open, so parentheses. And it keeps going to infinity. So now it'll be like two parts. So that's what it'll look like both on the graph and the interval notation. This is what it would look like for your inequality answer. So let's do a couple so you see how this works. So for number 1, we would solve both of these things separately. What we do to one, we do not do to the other. Solve them as two separate inequalities. So for this one, we would add 4 to both sides. For this one, we would divide 2 on both sides. Make sure you have that or in between them. Graph them both. So open circle at -3, going to the left. Closed circle at 6, going to the right. And then interval notation, where does this start? If it keeps going to the left. -infinity. And then where does this one stop? -3, would that be a parenthesis or a bracket? Mm-hmm. Or, then where does it start again? Mm-hmm. And that would be a bracket because it's closed. And where does that end? Infinity. With parenthesis. There's a parenthesis there, it's just blocked off. Before we do another one, do we have any questions on that? The process itself is not that bad. It's really taking what we did before, solving it, but now we're just solving it twice, and then having to graph it and put the interval notation. So let's do another one. Let's do 5. Anyone still writing this down? Again, 4, 5, solve these separately. So for this first one, it can actually be done 2 ways. So I'm going to show you one way, solve it like normal, and then go back and show you the other way. So distribute, so we get negative 6x minus 3 is less than negative 15. Add 3 to both sides. We have negative 6x is less than negative 12. And divide both sides by negative 6. Keep in mind that when you're dividing, your sign changes direction. So this is now greater than. Yeah.
Can you change it like every time you're dividing? Or just
anytime you divide by a negative. Or multiply by a negative. So usually towards the end. But I'll show you that when we do this the other way, we're going to do that at the beginning. So then for our other one, we would get rid of the 1 by subtracting. Divide both sides by negative 1. Our sign would change directions. So our final answer, we have x is greater than 2 or x is less than negative 4. If you want to put it in order of how it's going to look, you can. Usually whatever is less than will be on the left. Whatever is greater than will be on the right. You don't have to do that. If you want to leave it like this and just write or in between it, you can do that too. Either or. So then x is less than negative 4 would be closed to the left. X greater than 2 would be open at 2 to the right. How would we write that interval notation? What are we starting at? Is that where we start? Reading left to right?
It would be
negative infinity. Then we stop at negative 4 with a bracket. Or we start again at 2 with a parenthesis and go to infinity with a parenthesis. Right, somewhere where you have space, it may be in this portion. Do this just so you have it for later. I'm just going to resolve this part, but a different way. So instead of distributing, because 3 is a factor of 15, I could divide both sides by negative 3. But because I'm dividing everything by a negative, my sign is going to change directions. And then I would keep solving from there. So you get the same thing either way, as long as your math is correct. Questions on that second way, or this problem in general? Okay. So now let's talk about the other type. We talked about or, how they graph apart. Really, you need to know that these two are opposites. So if type 1, the OR inequalities graph apart, these have a tendency to graph together. So you might see it like this at first. X is greater than or equal to -6, and X is less than or equal to 1. So again, graph that like you would normally. So that would be closed, going to the right, and closed, going to the left. What happens is they overlap, and that overlap is what we're looking for. So from -6 to +1 is what we're looking for. So as you're getting used to it, you can still do both and then draw the overlap separately. Eventually, I need to see the overlap. If you just want to do the overlap, that's fine. Sometimes it's hard to see the overlap without drawing both. If you draw all three, that's fine. If you just draw this one, that's also fine. So then the interval notation of just this would be from -6 to 1. These are both closed, so these would both be in brackets. No infinities for this one. And then because the solutions to an and inequality fall between two endpoints, they're frequently written in a more condensed form. So I'm going to take the one we had. Write those two inequalities. But when we write our and answers, they're going to be from this number to this number with x in between. They're both going to be equal to because they both have a line. No matter what, whether one says greater than, one says less than originally, they are both going to be less than because this is saying from -6 to 1 and everything in between. Questions about that before we continue? So now that we know what that's going to look like, let's try number 6. Again, opposite of the OR, where we solve those separately, don't do the same thing to both. Here we do everything together. What we do to one side, we do to all sides. So if I subtract 4 from the middle, because I'm trying to get the x in the middle by itself, we're going to do that to all sides. So this would become -2 is less than or equal to x, which is less than 5. If it's already in this format, you don't need to graph both arrows, but I'll show you how that works anyway. If I were just graphing this, I would start at -2. That would be closed. I would end at 5. That would be open. And I would draw a line between them. If you wanted to do them separately, you would have to read each part separately. So I'd have to look at one part. X is less than 5. So start at 5, make it open, go to the left. And then look at the other part, but read it backwards. X is greater than or equal to -2. And then you could see that they overlap exactly where we said it did. So are the arrows necessary? No, you can do them if it helps you see it though. The interval notation is still going to be just where they overlap. From -2 to 5. -2 is closed, so bracket. 5 is open, so parentheses. Some of these will have bracket, parenthesis, 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 bracket, bracket. There'll be a mix. What questions do we have on that one? If this is closed. If solving it all together confuses you, you can take this middle part and set it to both. So that would look like this, and then this. Solve them separately, and then go back and draw it. If you separate them, you're going to end up with the two arrows, but you still have to draw where they overlap. But either or is fine. Let's do one more. Let's do 10. For number 10, I'm going to show you two ways also, but first, let's distribute. If we were trying to get x by itself, what would we do first here? Add 12 to everything. So we're going to end up with 10 is less than 2x, which is less than or equal to 16. And divide everything by 2. So 5 is less than x, which is less than or equal to 8. Before we graph this and do the integral notation, if the inside happened to be negative, your signs would still change. So I'm going to make up an example really fast. If this was negative and I divided everything by -2, all of my signs would change directions. But reading this, it still needs to be least to greatest. And -8 is smaller than -5, so I would switch this around so it's still in this format. So that will just have to be something you keep in mind, that the signs will still change and you might need to rearrange it. Going back to the problem, you'd have an open circle at 5, a closed circle at 8. Sometimes the line is really small. Sometimes it's really big. It depends. Our interval notation would be what? And then 8 bracket. And 8 bracket. If you wanted to make sure this is indeed where they overlap, x is less than or equal to 8 would be a closed circle at 8 going to the left. Reading this backwards, x is less than 5. Sorry, x is greater than 5 would be 5 going to the right, and that is where they overlap. Right. Just like a couple problems ago, there is another way to do this because all of these numbers are divisible by 2. If this wasn't the case, then I couldn't do this. So I'm going to rewrite this problem. And instead of distributing, I'm going to divide everything by 2. So we have -1 is less than x minus 6 is less than or equal to 2. And then add 6 to all sides. You get the same thing either way. questions do we have on that one? Christine. I was just going to ask what questions we want to see, so we'll do 9. Okay. Look through the and the or examples. Look through the very last page. Find any you want to see, go over, have questions about. Maybe it looks challenging, you're not sure where to start. Anything like that. And on that. Any others? Okay, so let's start with 9, and then we'll go to 10, and then I'll show you the two examples on Khan Academy, and then you'll have 10 to practice. All right, so for 9, we would need to get rid of the 1, so subtract that on all sides first. To get rid of the 2/3, what would I do there? Multiply by not 2/3, but 3/2 if we flip it. But we have to do that to everything. So we have 3 times -2 is -6. -6/2 is -3. Is less than x. Is less than or equal to 4 times 3 is 12. 12 divided by 2 is 6. And then you can graph it. We have open circle at -3, closed circle at 6. If you want to do the other ones, you can. What would the interval notation be? Where does it start? Would that be a parenthesis or a bracket? Parenthesis for the first one, starting at -3. And then going to 6, and would that be parenthesis or bracket? Great. Other questions on that one? Okay. Number 10 on the back. Just by looking at this first, is this going to be an and or inequality? And, because it's all condensed. Okay. So we can either distribute the 1/2 or multiply everything by 2. Which would we rather? Doesn't matter. Multiply or distribute? Multiply. Okay. If you want to distribute instead, you can still do that. So I'm going to take this and multiply it by 2, multiply this by 2, and this by 2. The 1/2, yeah, I took it and flipped it. -78 is less than or equal to 10x minus 18, which is less than or equal to 32. Add 18 to both sides. We have -60 is less than or equal to 10x, which is less than or equal to... Someone tell me what it is. 50? I think it's 50, but someone double check that. plus 18. Right, divide everything by 10. We have negative 6 is less than or equal to x, which is less than or equal to 5. Then we could graph this. These will both be closed. So since they're both closed, your interval notation will have 2 brackets. Questions on that one? On the back of your notes, where you have blank space, write down these examples as I do them. Alright, so this first one says 12x plus 7 is less than negative 11, and 5x minus 8 is greater than or equal to 40. Write those two down. Make sure it says and in between so you know that it's an and, so when you go to do this later, you know which one it was. With these problems, you're going to solve not like what we did where you solve it all together, solve each one separately, kind of like a OR. I forgot how to put this one is. A lot of these answers are going to be fractions. If I divide those both by 6, I get negative 3 over, 2. And then solve the other one. So add 8 to both sides. Negative 11 minus 7. And then divide both sides by 5. If you need to figure out what those are as decimals, so it's easier to make a number line, and you're going to make like a makeshift number line off to the side. All right, so negative 3 over 2 is negative 1/2. 48 over 5 is 9.6. So we want to draw our number line that has both of these things. You might have to skip some numbers. So let's see, 10, 8, 6, 4, 2, 0. You'll have more space than I do. I just don't have that space right now. And then negative 0.5 would be here. You can use whatever numbers you want. If you want to count all the way up between these, you can. I just don't have that much space. So this says x is less than negative 1.5. So open circle going to the left. X is greater than or equal to 9.6. Closed circle going to the right. And is still overlapped no matter what. Do these overlap? No. So then the answer would be there are no solutions. This is the only time you get no solution. So and is still overlapped no matter what. Drawing your number line will help you see that. If they did overlap, you would say wherever they overlap. Okay, let's do one more. Right. Now you have an or problem. Negative 4x plus 60 is less than 72. Or 14x plus 11 is less than negative 31. And has to overlap or should not overlap. Or you're looking for where it doesn't overlap. Okay, so solve this. Solve each one separately. Subtract 60 on both sides. Divide both sides by negative 4. Remember that your signs are going to change. Then do the other one. Subtract 11. And divide both sides. So that x is less than negative 3. And then again, graph your number line. Here, these both happen to be the same number. One is saying that it's greater than. The other is saying it's less than. We're looking for places where they do not overlap. Is there anywhere where they do not overlap? And this one's a little tricky. I was thinking at 3. Here, because of what it looks like, they're overlapping everywhere until they get here. Technically, they're not overlapping there because they're not included, but that's not the answer. So this would also be no solution. Oh, just kidding. Why is this solution? It's not. I said that wrong. But it's not either of those. Let's yes, and check. It's not that one either. Okay. So this one, I was thinking the wrong thing because I did one of the other ones and it was weird. Technically, they aren't because they're both open. They're not overlapping there, so that's still okay to say. If they were both closed, that would be no solution. That's what I was thinking. So as you're doing this, if you need my help, let me know. Okay. So for the remainder of class, you can practice the problems in the notes. Do the Khan Academy so you don't have to worry about it. Let me know if you need my help on any of those.